We're not quite into calculus yet. Okay, so this is what I got. Hold on. Sorry. So I got 36y squared minus 25 equals 0. Go ahead, next line.
Okay. So because of the y squared, can't you just take the square root of the whole thing? You could do 6y minus 5 is 0.
No.
And then you could, no?
Any more than if I said x squared minus 4 is equal to 0. I can't take the square root of each part and say x minus 2 is equal to 0.
So
And
you just got to move
I can't is because x minus 2 times x minus 2 is not equal to x squared minus 4. Notice x minus 2 squared is x squared minus 4x plus 4. So you can't go the other way around either. You can't take the square root of that and come up with x minus 2. So you've got to do this the more normal way, which we want to get it down to y.
So add the 25.
It's got the y in it. There's actually a couple of ways to do this. I'm going to show you both. Let's do it the way most people would do it, first of all. Let's move the 25 over. Okay, now what?
Take the square root, both of
them? We want to isolate that before we take the square root of both sides.
Let's divide by 36.
Okay. Now, notice both of those are perfect square numbers. So what's y equal to?
5 over 6.
When you are solving an equation by taking the square root of both sides, always begin your answer with what words?
Y or
plus or minus.
Oh, plus or minus. Oh, yeah.
That is the hardest thing for me to teach students. It's because I don't have a little song. If I had a nice little tune to it, they could remember it, like your ABCs. Or I know there's a song for memorizing the quadratic formula. But I'll be darned if there's a song for teaching people to answer with a plus or minus. But that's what you need. If you leave off the plus or minus, you'll lose points, for sure. You'll lose at least half credit. Now, to avoid making that mistake, there's actually a different way I can do this problem. Notice we are looking at the difference of perfect squares, right?
Mm-hmm.
That is a perfect square, that is a perfect square, and they are being subtracted. So we're looking at the difference of perfect squares. So the answer is 6y minus 5 when I factor difference of perfect squares times 6y plus 5. Now you can't make a mistake. Now if you set each one to 0, you get y equal 5/6 or y equal negative 5/6. So this is actually the preferable way to do it because it's so easy to make that mistake. I make that mistake 20% of the time, where I forget the plus or minus. But my students make it about 90% of the time. And you can't make it if you do it as factoring difference of perfect squares. Not, maybe you can read this. Oh, no, I can see it. Hold on.
Yeah, the first two wouldn't focus. The camera wouldn't.
Okay. My first step here.
I'm not sure.
Well, notice it's a cubic. Cubics don't handle nicely. You think quadratics are hard, cubics are brutal. You still have to set it equal to 0. Initially, it looks like I could turn this into a quadratic by factoring out an x. But then I'm going to have x times some quadratic equal 5. Well, I can't solve that. I can solve it if something's multiplying together and equaling 0, but I can't solve it if it's equal to a number. So I got to bring this 5 over on the left side. Now, the one thing to know about cubics, they are hard as hell to solve, unless they meet a specific pattern that allows you to solve them by grouping. So when you see a cubic, almost certainly it's either solvable by grouping or not solvable. I don't know if you've had the math yet to factor cubics. You heard of the rational quotient or the rational factor theorem or the zero remainder theorem or any of those?
Nope.
Then you haven't had it. So what that means, that's a good thing. That means if they give you a cubic to solve, then it must be solvable by this grouping. And what has to be true for something to be solved by grouping is that the ratio of the first two coefficients has to be the same as the ratio of the last two terms. Well, there's a 1 right there. So the ratio of the first two coefficients are 1/5. The ratios of the last two coefficients are also 1/5. That means we can solve it by grouping. And that has to be true, always. If I make that a 4 instead of a 5, no way. Can't solve it by grouping. Can't solve it any other method that I know of. Well, no, truly, I mean, cubics are a nightmare. Just trust me. When you get to them, you'll say, what in the world? I thought quadratics were hard. But if they're groupable, then we're going to group them. And by grouping them, I mean we want to put those together and we want to put these together. Now, I can put parentheses around those two terms without changing anything. But how do I have to write the next two terms with parentheses so that I do not change this equation?
Do you have to include that negative in front of the x?
Well, you just have to make sure you don't change it. So what needs to go in the parentheses?
The x minus 5?
Well, I'll write x minus 5. Now you tell me if that's the same as what I started with.
The negative?
Not, is it?
Mm-hmm.
In other words, if I now remove these parentheses, I apply the negative to the x, I apply it to the minus 5, and I end up with x plus 5. So this can't be right. But what if I make that a plus? Now, that is identical to that. And that's what you have to do. If you're going to group by adding parentheses, and if that is a subtraction sign, then you always are going to have to change the sign on that term from whatever you were looking at to begin with. The key is to just make sure you end up with the same thing at every single step. That's the key to a lot of math. Making sure that you don't change it from, when you're completing the square, it's exactly the same thing. When you're completing the square, your sole goal is to make sure you do not change it from one line to the next. You're manipulating the equation a little bit, but you're not changing it. In other words, I could always go from there backwards and get back to that. Okay, now that I've got it like this, factor the greatest common factor out of the first set of parentheses. What do you get?
Is it the x squared?
And what's left over?
What is it? X plus 5?
Okay. And I can't factor anything out of that, but I still got an x plus 5. Okay. Now, the next process is one you're not particularly used to. But if I told you you could take a greatest common factor out of that, what would it be?
X plus 5?
Exactly. It's a binomial. That's what you're not used to doing. Probably everything you've ever factored in your life has always been monomial terms. What's left over?
X squared?
Minus 1. In other words, when you factor an x plus 5 out, you divide that term by x plus 5 to get x squared, and you divide that term by x plus 5 to get 1. Okay? Now I'm going to move to the top just because I'm out of drawing space. So here, let's look at the top, because now I'm down to this. And what do I notice? I factor anything else.
Wait, so for the x squared plus the x squared times x plus 5, what did you do for the first one? You divided that one by x plus 5 too? Oh, wait, no, never mind. So you're just left with x squared plus 1.
When you take a greatest common factor, you are dividing by that term. Let's say I have this. Here, I'm just going to give you a quick example. What's the greatest common factor I can take out of that?
2x squared.
Okay. Now, when I say what's left over, the way I get it is by dividing both terms by my greatest common factor. Okay. This is x squared. This is 2. That's how you do it. In other words, when you take a greatest common factor out, what you are doing is dividing both terms by that greatest common factor. And that's what I did on the previous problem. Only the greatest common factor was x plus 5. So I had to divide both terms by x plus 5. And that, what was left over was x squared minus 1. Now, I'm not done factoring. I'm not done factoring. There's more factoring. What's x squared minus 1 equal to? Can you factor it?
Not sure. I don't think you can factor that anymore.
Difference of perfect squares. 1 is a perfect square.
So just x minus 1, x plus 1?
Uh-huh. And there's our 3 solutions. What are they?
X is negative 5, x is negative 1, and x is 1.
Yeah. So that's factoring a cubic. And the only ones they're going to give you are the ones that you'll be able to do by grouping. And just as a check, this is what we had. You will know you've made a mistake if that's not the same as that. In other words, if this says x minus 5, and that's the most likely mistake you can make, right?
Mm-hmm.
That's what you wanted to do originally. If I'm looking at an x plus 5 and an x minus 5, I know I've made a mistake. Because that means I can't do it by grouping, and if I can't do it by grouping, they wouldn't have given it to me. So that has to be x plus 5. You could almost not even bother to go back and find your mistake, just turn that into the same thing that that is, and then proceed from there. Not sure I've ever given that as a math tip, but I just did. All right, let's look at your third page here. Ooh, nice and clear. Clear enough that I can blow it up a little bit again. Well, not that much. 7. You start there?
Yeah.
Okay. Thinking for a moment. Usually when you have a log equation, the way they want you to solve it is by putting it into one log term on the left,
Mm-hmm.
converting it to exponential format, and solving it. So let's do that. So, well, hold on 1 minute. Maybe we don't need to do that. You know what? Actually, an easier way we could do this. Let's factor that out. There is a greatest common factor here. What is it? Natural log of x. So,
2 natural. Wait.
well, okay. Yeah, I can do that. 2 natural log of x, greatest common factor. That leaves x squared there minus 4 equals 0. How about x squared minus 4? Can I factor that?
Yeah.
Okay. What makes that 0?
That's 0.
Mm-hmm. What value of x makes that 0? Because that's what we have to figure out. In other words, we have 3 numbers multiplied together equaling 0. So we have to make that 0 and solve for it. We got to make that 0 and solve for it. And we got to make that 0 and solve for it. So what is the solution to this? 2 natural log of x equals 0. What value of x makes that true?
0.
No, 1. You actually cannot take the natural log of 0. That violates the domain. It's like taking the square root of negative numbers. You can't do it. You can't take the natural log of negative numbers, and you can't take the natural log of 0. But this, x has to be equal to 1. The only number that the log of 1 is always 0, no matter what its base is. Okay? So that solution gives us x equal 1. Plus we have an x equal minus 2, and we have an x equal 2. So those are the three solutions. Now, do any of them violate the domain? That's always what you have to ask yourself when you're doing log problems. When you're
Okay,
solving log equations, very many of them violate the domain. But
so would the x equals -2 then? Because you said they couldn't have negatives.
So that is not a solution. But the other two are fine. Notice that 1 works, because that whole thing's going to become 0. 0 minus 0 is equal to 0. And 2 is going to work for x. It just does. And the reason I don't have to check is because it doesn't violate any domain. You can square 2, you can take the natural log of 2, and you can take the natural log of 2. So the only ones I'm going to throw out are the ones that violate the domain. Okay, let's try to do one more here. Am I looking at it? All of it? What's the rest of that? Is it equal to 0?
No, there's more.
Why don't you read it to me?
So it's plus 4x cubed.
Here.
And then in parentheses, 4x plus 1.
I'm going to have to start from the beginning here. Plus what?
Plus 4x cubed. And then in parentheses, 4x plus 1.
In parentheses, 4x plus 1, like that.
And then squared after the parentheses. Yeah.
And then equals 0?
Mm-hmm.
Okay. Let's talk about greatest common factors. What's one that we can take out?
X squared.
Yeah, I'm going to do these separately, just because I don't want anybody to get confused. So, it's x squared times, hold on a second,
4x plus 1 squared.
yeah, that's another one. I guess we can do it in the same step. So let's just do that. We can see that both of those will come out as factors. The question is what's left behind? Well, how about this part here?
X and times 4x plus 1.
I think it's 3 times 4x plus 1.
3.
So 3 times 4x plus 1, let's just write it like that for the moment. And then over here, what do we have?
4x.
That's it. Okay. Now distribute that, and we have 12x plus 3. Simplify that, and you have 16x plus 3. And so now what we have is x squared times 4x plus 1 squared times 16x plus 3 equals 0.
Okay.
So now what? What are my solutions? Start from left to right.
Well, for the x squared, it's just 0, right?
Okay, yeah. So that's one solution. Obviously, if that's 0, the whole thing is 0. And now what makes that 0?
Negative 1/4.
Yeah. And only that. And finally, what makes that 0?
Negative 3/16.
There you go. All three of those answers. Now, when I'm looking at a polynomial like this, I'm not really too concerned with extraneous solutions because the domains are all real numbers. In other words, I'm not dividing by x. I'm not taking the square root of anything. So there's no way any of those values could violate the domain. And each one of them will give you the -4 makes that 0 and that 0, or the -1/4. So I'm confident that all three of them work. Okay?
Okay.
Good to go, Sam?
Mm-hmm.
All right. I will talk to you next time. Bye-bye. You were just doing a half hour tonight, right?
Yeah.
Okay, good. Talk to you later. Bye-bye.
Thank you.